Hello Senior High, it's me again, your Sir Michael. How are you today? I hope you're all doing great. Welcome to another episode of our online learning. But before we start our lesson, please make sure that you are in a very comfortable place at home. Stay in an area where there is a stable internet connection. Stay away from noise and stay away from any kind of distractions. And also, make sure that you already have with you your ballpen, your skill notebook, and of course, your learning module in statistics and probability. Do you have these things with you now? If your answer is yes, then great, we can now begin our lesson. Yesterday, I already introduced to you your performance task along with the rubric for this quarter. Also, you learned about population and sample as some of the many significant terms in studying statistics. Now let's see if you can still recall the things that you have learned by completing this paragraph that I have prepared for you. Hold with your ballpen and number your skill notebook from 1 to 4. Are you ready? Alright, here we go.
In statistics, the entire group that you want to draw conclusions is called blank, and collecting data from this is done through a blank. While the blank is the specific group of individuals that you will collect data from, and the process of collecting information from this is called blank. Go!
Are you done? Okay, let's check your work. In statistics, the entire group that you want to draw conclusions is called population, and collecting data from this is done through a census, while the sample is the specific group of individuals that you will collect data from, and the process of collecting information from this is called survey. How's your score? Perfect? 2 mistakes? What is the census again? Can you now differentiate census from a survey? Yes, we called it census when we are collecting data from a population, and we call it survey when we're only collecting data from a part of the population, or what we call sample. So I hope that from now on, you can clearly distinguish the difference between population and sample, and also the difference between census and survey. Is there a time in your life where you participated in a census or in a survey? Or have you experienced conducting a census? How about a survey? For census, I think it's definitely a yes for all of us, because just last year, in the middle of the pandemic, the Philippine Statistics Authority or PSA conducted the 2020 Census of Population and Housing. Yes, it's a census, meaning all of us are included in the data gathering. I have personally experienced it last year, last September 1 to be exact. How about you and your family? For survey, I think all of us have experienced it many times, because as students, conducting researches as early as junior high school up to now has always been part of our curriculum, and there's still more to come, of course. Yes, so let's try our best to study harder, just like what we are doing today, okay? So much for that. I want you to prepare your skill notebook again, number it from 1 to 5, and do this activity as fast as you can. Are you ready? Here we go.
Here are the top 25 most popular given names in the world over the last 100 years. List down the 5 numbers that will appear in the random number generator, and after which, write its corresponding names from the given table. For example, if one of the numbers that will appear in the random number generator is 11, write David correspondingly to it. So set your focus on the random number generator. Go! Time's up! Now let's check your work. The numbers that appeared in the random number generator are numbers 17, 6, 23, 4, and 19. And its corresponding names are Thomas, Jennifer, Daniel, Patricia, and Charles respectively.
So how's your performance? If you get a perfect score of 5, then great. If you get 3 to 4, good job. If you get a score of 0 to 2, nice try. Do not worry because we're still on our first activity and I still have plenty of activities for you. So keep your focus and prepare for the next game.
Using your skill notebook, rearrange the following 3 groups of jumbled letters to form 3 separate words. Number your work from 1 to 3. RF, Acule, Sivogite. Go! Are you done? Now check your work. The answers are the words fair, equal, and objective. Did you guess it?
So how's your performance again? I hope you're all enjoying the activities I'm giving you so far. The words fair, equal, and objective will be playing an important role for today's video lesson. So class, please take note of these 3 words. Today, we will be learning one of the most important steps in conducting your research, which is very necessary before you proceed to the gathering of data from your samples. And what is it? It's random sampling. At the end of this video, you're expected to correctly illustrate random sampling. And not just that, you're also expected to perform one of the types of random sampling, which is the stratified random sampling technique. But hey, please do not worry because again, I will be with you throughout this entire journey. All I want you to do is to honestly and actively participate in all the exercises and activities that you will be encountering in this lesson. Now, hold with your ballpen and your skill notebook and prepare for the next activity. Are you ready? Let's begin.
Given the list of 26 letters of an English alphabet, identify the other 6 remaining letters by counting an interval of blank starting from the letter blank. What are the 6 other letters?
In this activity, just to be fair and equal, allow me first to draw a letter from this fishbowl that will serve as your starting point. Then after that, I'll draw a number from another fishbowl that will serve as your interval. The letter is letter B. And the number is number 4.
So, given the list of 26 letters of an English alphabet, identify the other 6 remaining letters by counting an interval of 4 starting from the letter B. What are the 6 other letters? Go! Are you done? Now check your work. If you have correctly followed the condition, the other 6 letters are letters F, J, N, R, V, and Z.
Were you able to identify these letters correctly and completely? If yes, then great! Keep focused and prepare for the next activity.
Given 6 groups of codes, list down all the codes which belong to the group that will be randomly selected from the fishbowl.
This fishbowl contains 6 pieces of papers which are numbered from 1 to 6. But I will only be drawing 3 papers in random to be fair and equal. Are you ready? Okay, list down all the codes which belong to Group 4. List down all the codes which belong to Group 3. And list down all the codes which belong to Group 1.
Are you done? Now check your work. The complete list of codes based on the randomly chosen groups are C1, A3, B5, A2, B6, C4, B1, A4, and C6.
Were you able to write down all these codes completely? Very good! Now keep focused and prepare for the next challenge.
Given 4 groups of numbers, list down all the identified numbers according to the position chosen randomly from the fishbowl.
In this activity, you will only get 2 numbers from each of the 4 groups. But to be fair and equal again, we will be drawing a position as to which of the 5 numbers will be selected. This fishbowl contains 5 papers to denote the 5 positions of the 5 numbers. Are you ready? Okay, from group 1, choose the second number and choose the 5th number. From group 2, choose the 4th number and choose the 1st number. From group 3, choose the 4th number and choose the 3rd number. And finally, from group 4, choose the 1st number and choose the 5th number.
Are you done? Okay, let's check your work. Based on the randomly chosen papers, the numbers must be 9, 15, 13, 6, 5, 16, 1, and 19.
How's your performance? Were you able to correctly identify these 8 numbers? If yes, then great. If you missed some, do not worry. Remember, mistakes are just part of our learning, okay? But class, did you know that you have already illustrated random sampling without knowing them formally? Yes, all the activities that you have participated since the beginning are already about illustrating random sampling. So what do you think is random sampling?
By definition, random sampling is also known as probability sampling and is undertaken by the researcher to achieve unbiased results in his or her study by selecting samples in a fairer manner.
Let's discuss it this way. Yesterday, you have learned that for most of the time, we cannot study the whole population because of a lot of factors such as time and money, among others. So instead of studying the population, we only studied a part of the population, or what we call the sample. And since a researcher must always be fair, equal, and objective in the conduct of his or her study, he or she should not only do sampling, but most importantly, he or she should do random sampling. Why? Simply because random sampling is the most valid technique in selecting the samples. And by random, we mean we're giving equal and fair chances to all the members of the population to be selected in order to be part of the sample. And there are 4 major ways to do random sampling. And how do we do them? Very easy, because you have already made it during the activities given earlier. So sit back, analyze, and take down notes.
For example, when I asked you earlier to list down the 6 given names among the 25 most popular given names using the 6 numbers that appeared in the random number generator, you have illustrated the first type of random sampling, which is called the simple random sampling. As the name speaks for itself, simple random sampling is the most basic type of random sampling, wherein members of the population are treated individually, and samples are randomly selected, mostly through random number generators or with the use of fishbowls. The second type of random sampling is called the systematic random sampling. You have done this technique earlier when I tasked you to identify the 6 remaining letters after randomly selecting B and getting the other letters using an interval of 4. Just like the simple random sampling, members of the population are treated individually in systematic random sampling. So in here, we have a total population of 26 and only selected 6 samples. What's the clue for us to tell that it's a systematic random sampling? Yes, interval.
Whoa! Were you able to follow, class? What are the first 2 types of random sampling again? Very good! The simple random sampling and the systematic random sampling. Their similarity is that they both treat members of the population individually, but the simple random sampling chooses samples in random, meaning there is no pattern, such as this one. And the systematic random sampling selects samples through an interval or regular spaces, just like this one. So now keep your focus and let us learn the remaining types of random sampling.
The third type of random sampling is the cluster random sampling. An example of this is the activity which I gave you, wherein I let you list down all the codes that belong to the group which I randomly selected using a fishbowl. Look closely. Here, the members of the population are no longer treated individually, but they will be treated according to their groups, or what we called clusters, where its name is derived from. To get the samples using cluster random sampling technique, clusters are randomly selected and all members of the selected clusters will automatically be included in the list of samples. Hence, in our activity, the samples are C1, A3, B5, A2, B6, C4, B1, A4, and C6 because the randomly selected clusters are cluster 4, cluster 3, and cluster 1. The fourth type of random sampling is called the stratified random sampling. You have also done this sampling technique already. Remember the latest activity wherein you are tasked to list down 2 randomly selected numbers from each of these 4 groups? Yes, that's how stratified random sampling works. In stratified random sampling, members of the population are divided to form groups called strata, hence the name stratified, and samples are randomly selected from each stratum, meaning you must not skip or disregard a single stratum when getting samples, unlike in cluster random sampling, wherein we totally disregard the clusters that have not been randomly selected.
Whoa! Do you find the last 2 types of random sampling a bit confusing? If yes, do not worry, I'll discuss them further. Cluster random sampling and stratified random sampling are somewhat similar because they both involve groupings of the members of the population. Only that, in cluster random sampling, these groups are called clusters, while in stratified random sampling, the groups are called strata. Their only difference is that, in cluster random sampling, once a cluster has been selected, automatically all the members of that selected cluster will be included in the samples, and we can immediately forget or disregard the clusters that have not been selected. While in stratified random sampling, we do not randomly select a stratum. Why? Simply because we need to get samples from all strata via either the simple random sampling, or we can also use the systematic random sampling in getting the individual sample from each stratum. In stratified random sampling, no single stratum will be disregarded. Is that clear? I guess you can now slowly distinguish the 4 basic types of random sampling. What are those again? Very good! The 4 basic types of random sampling are the simple random sampling, the systematic random sampling, the cluster random sampling, and finally, the stratified random sampling. So now let's see if you can identify what type of random sampling is being illustrated by the image that will appear on your screen. Are you ready? Let's begin.
What random sampling technique is this? The population is divided into 4 groups, then group 1 and group 4 have been chosen as samples. Very good! Cluster random sampling. Next, what random sampling technique is this? 7 people have been assigned with numbers, and numbers 2, 4, and 5 have been chosen using an auto-generate random selections to complete the samples. You're right! This is a clear example of simple random sampling. Next, what random sampling technique is this? The population is divided into 2 groups, and 2 samples are chosen from each group. Great! This photo exhibits the characteristics of a stratified random sampling. How about this one? What random sampling technique is this? The members of the population have been assigned with numbers, then starting from number 2, other samples at an interval of 3 were taken. Very good! I think this one is your favorite, the systematic random sampling.
Well done, class! I am very happy to know that you are showing improvements today. But how about if we put these sampling techniques in real situations? Do you think you can still identify what type of sampling technique is being applied if you're only given a sentence? Are you ready? Let's try!
Number your skill notebook from 1 to 4. Study the given real-life situations and analyze as to what specific sampling technique is being used in each scenario. Number 1. Mr. De La Peña selects the subject of his study by selecting every fourth student on their chairs. Number 2. A sample of 20 patients are selected at random from a set of 100 patients to test the effectiveness of a vaccine for COVID-19. Number 3. The Department of Health polls 1,000 men and 1,000 women about their views concerning the use of face masks and face shields. Number 4. A Litany researcher interviews all diabetic patients in each of 10 randomly selected hospitals in Region 8.
Are you done? Now let's check your work. Number 1 is a clear example of a systematic random sampling because here, Mr. De La Peña uses an interval in selecting his samples. Like in the problem, the interval is 4. The answer for number 2 is simple random sampling. Why? Because from the population of 100 patients, the 20 patients are simply selected randomly. Number 3 is an example of a stratified random sampling. The strata here are the groups of men and women, and from the stratum of men, 1,000 are selected, and from the stratum of women, another 1,000 are also selected. Lastly, number 4 illustrates cluster random sampling. Here, all hospitals in Region 8 act as clusters, and this Litany researcher interviews all diabetic patients only from those randomly selected 10 hospitals. How many correct answers did you get? If you get a perfect score of 4, then great. But if you still made minor errors, then clearly analyze each problem next time, okay? But class, how do we actually count the number of samples to be taken from each stratum if we choose to apply the stratified random sampling technique in a research or study? Such as in this case, wherein the size of the members of each stratum is different from each other.
Let's learn further. To compute for the exact number of samples to be taken from each stratum if the researcher wishes only to study 50 samples from the given data, the first thing to do is to know the total size of the population. To do that, simply add the sizes of all strata. In this case, 38 plus 20 plus 32 plus 45 equals 135. Therefore, the total population is 135. Next, to compute for the number of samples to be taken from each stratum, simply divide the size of that stratum by the total population and multiply it by the desired number of samples. In this case, the desired number of samples is 50. For example, for stratum 1, divide 38 by 135 and then multiply the answer by 50. The answer is 14.07. For stratum 2, divide 20 by 135 and then multiply the answer by 50. The answer is 7.41. For stratum 3, divide 32 by 135 and then multiply the answer by 50. The answer is 11.85. And finally, for stratum 4, divide 45 by 135 and then multiply the answer by 50. The answer is 16.67. If you can observe, the number of samples to be taken from each stratum includes decimals, and we know that this is not applicable if we are dealing with people because the number of people needs to be exact, right? So what will we do? It's easy. Round off all answers to make them whole. So 14.07 will become 14. 7.41 will become 7. 11.85 will become 12. And 16.67 will become 17. So that if we add 14 plus 7 plus 12 plus 17, the answer is 50, or the total desired number of samples. So take note of this formula in computing for the number of samples to be taken from a stratum. Size of stratum divided by the total population times the desired number of samples.
Wow! That is very informative and useful, and I hope that you guys were able to follow. So do you have any questions so far? If you have no more questions regarding our discussion and with all the activities that you have participated, it is now your time to think and come up with your own answers to these following guide questions.
When can you say that the sampling being performed is valid and good? What is random sampling? How do you conduct simple random sampling? How do you perform systematic random sampling? Can you differentiate cluster random sampling from stratified random sampling? How do you perform stratified random sampling?
Do you have answers to those questions? Now let's summarize our discussion for this day.
A sampling is valid and good if the researcher is objective. He or she selects samples at random, which means that every sample in the population has a fair and equal chance of being selected. This sampling technique is called random sampling. The four basic types of random sampling are simple random sampling, systematic random sampling, cluster random sampling, and stratified random sampling. The simple random sampling is also called the basic random sampling. Every member of the population has an equal chance of being selected. To conduct this type of sampling, you can use tools like random number generators, fishbowl, rolling a die or dice, or any other techniques that are based entirely on chance. The systematic random sampling is similar to simple random sampling, but it is usually slightly easier to conduct. To perform this type of sampling, list every member of the population and assign a number, but instead of randomly generating numbers, individuals are chosen at regular intervals after randomly selecting a fixed point. The cluster random sampling involves dividing the population into subgroups called clusters, but each cluster should have similar characteristics with other clusters. To conduct this type of sampling, randomly select a cluster and list all members of the selected cluster to be part of the sample. The stratified random sampling involves dividing the population into subpopulations called strata based on common characteristics such as race, age, sex, religion, income, and the likes. To perform stratified random sampling, calculate how many people should be sampled from each stratum based on its proportion to the whole population. The bigger the proportion of the stratum, the greater number of samples will be selected from each stratum by either a simple random sampling or a systematic random sampling.
Are those things clear, class? Very good! Make sure to value this lesson because random sampling is a valid and most widely recognized sampling technique in data gathering. If you're not going to apply random sampling in your researches, your data might not be valid and the credibility of your findings might be questioned. So remember to always be fair, equal, and objective in all your researches, and most importantly, in your real life.
Let's master your skill in performing stratified random sampling. Using your skill notebook, honestly and independently answer the following exercise. As a grade 11 student taking practical research class, you are tasked to conduct a study in your barangay to know the perception of parents towards modular distance learning. You didn't think of applying a stratified random sampling because you understand that it is the best sampling technique to use in your study. Now, compute for the exact number of parents to be taken from each zone of your barangay if you only need 30 respondents in your research. Go!
Are you done? Okay, let's check your work.
First, we add the number of parents in each zones to know the total population. We have 24 plus 30 plus 19 plus 27 equals 100. Therefore, the total population is 100. Next, to compute for the number of parents to be taken from each zone, we will simply divide the size of each zone by the total population, which is 100, and multiply our answers by the desired number of samples, which is 30. So 24 divided by 100 times 30 is 7.2. For zone 2, 30 divided by 100 times 30 equals 9. For zone 3, 19 divided by 100 times 30 is 5.7. Finally, for zone 4, 27 divided by 100 times 30 is equal to 8.1. And since we need to have exact values, we will round off our answers to the nearest ones. Therefore, 7.2 will become 7, 9 will still be 9, 5.7 will become 6, and finally, 8.1 will become 8. so that if we add 7 plus 9 plus 6 plus 8, the answer is 30. And 30 is the exact number of respondents that you need in your research.
How's your performance? Perfect? Almost perfect? Good job! I think you're all ready to answer the assessment activity which I especially made for you. You may find it on your learning module. Just partially answer the assessment activity since some of the problems will still be discussed in the next video lesson.
So for your assignment number 1, I want you to have an advanced reading and note-taking on parameter, statistic, and sample mean in preparation for next topic. And for your assignment number 2, using your journal, have a reflection and answer the following questions. First, as a researcher, how will you properly conduct sampling before the gathering of your data? Second, why is it important for a researcher to be objective, fair, and equal in the conduct of his or her study?
That's it for today, class. I hope you have learned something from today's video lesson. But if you still have some questions regarding our lesson, please do not hesitate to contact me at my messenger account, Michael Raymond. This is me again, your Sir Michael, your teacher, your friend, who will keep on saying, please do not give up on your dreams because with the right attitude, someday you will become successful. Yes, you can. Yes, you will. Until our next video lesson, bye!